In this video, we're going to talk about how to divide complex numbers, and we'll give a few examples. So, say w and z are complex numbers, and z doesn't equal 0. So if we have w divided by z, what we're going to want to do is we're going to want to multiply w divided by z by the z conjugate. Okay. The reason why we do this is because z times its conjugate is a real number, right? It's the a squared plus b squared. Doesn't involve imaginary. And so if we want to get this into standard form, so right now it's not in standard form if it was a complex number divided by another complex number. This is the step that we want to do. Okay? This will make sense once we do an example. So let's go ahead and get to it. Let's do an example. Okay, so we're trying to solve this, or get this into standard form. So to get this into standard form, I'm going to multiply it by the conjugate of the denominator, which would be 3 plus I over 3 plus I. Okay? You see, this is just 1, so I didn't do anything. I just, I multiplied it by 1. But the purpose of doing this is to get rid of the imaginary on the denominator. Alright, so this would equal 5 times 3 plus I. And then I'm going to use the complex conjugate product theorem, which says that if you multiply a complex number by its conjugate, the answer is a squared plus b squared. So that would be 3 squared plus b, in this case it's just 1. Alright, and then I'm going to have, let me go ahead and distribute that 5, so then I'll have 15 plus 5i divided by 9 plus 1, which is 10. So I'll have 15 plus 5i divided by 10. Now to get this into standard form, I'm going to divide both things by 10. So I'll have 15 divided by 10 plus 5 divided by 10 times I. And 15 divided by 10 would be 3 divided by 2, okay, plus 1/2 I. And that would be your answer. Let's do one more example. Alright, so in this example, first thing I'm going to do is get rid of the negative inside the square root by using imaginary numbers. So I'll have 3 plus the square root of 4 times I. Square root of 4 is 2, so that's 2i. Then 6 minus the square root of 9 times I, which would be 3i. Square root of 9 is 3. Okay, then I'm going to multiply the top and the bottom by the conjugate of the denominator, which would be 6 plus 3i. 6 plus 3i. Okay, and then I'm going to have to FOIL the top. For right now, I'll just write it like it is. And then on the bottom, I'm going to use the conjugate, or the complex number conjugate product theorem. So I'll have a squared plus b squared. B is 3. All right. And then on the top, I have to FOIL. So 3 times 6 is 18, plus 2 times 6, 12i, plus, let's see, so then 9i, and then plus 6i squared. Okay, then this is 36 plus 9. Alright, so then I end up having, so let's see, I need to combine my like terms. So 18 plus, let's see, 9 plus 12, which is 21i, and then what's I squared? I squared is -1, so instead of it being plus 6, it's minus 6, okay, because I squared is -1, all over 45. Okay, and then I have, let's see, I need to combine the top a little bit more, so I end up having 12, 18 minus 6 is 12, plus 21i over 45. Okay, now let's just do, let's bring this 45 under both of the terms, so 21 over 45i. Okay, and then lastly, I just need to simplify. So I've kind of run out of room over there, so I'm going to do it over here. So 12 divided by 45 is the same as 4 divided by 15, because they both go into 3. And then plus, so 21 divided by 45 is 7 divided by 15, because they both go into 3. And then there you go. And then that's your answer.